In this video, we're going to learn about the metal activity series and learn why it's important to follow and how to identify whether a reaction is going to happen. So single displacement reactions, not all metals will be able to actually displace the metal that's in the compound. So to be able to do that, the metal has to be more reactive than the metal that's already in the compound. So the question is, how do we figure that out? So we use something known as the metal activity series. So in this series, here's some things. There's a couple of things that actually aren't metals in the series. So we have here carbon, and we have carbon here, and then we have hydrogen here. But we keep them in the series because they'll sometimes act like metals and bump things in and out of the reaction. So if we look here, we have these elements ranked. So the things at the very top are reactive metals, and the things at the bottom of the reaction are less reactive metals. So if you look down here at the bottom, this is actually important to note. We have silver, gold, and platinum, which are three metals that are used in jewelry. You don't want to use a reactive metal to make jewelry out of because it could react with the skin and the sweat on your hands, which is why some cheap jewelry can cause skin reactions and allergic reactions, and it's because those metals are more reactive and they shouldn't be placed in jewelry, but it makes the jewelry less expensive. So things up here like our alkali metals, and then there's alkaline earth metals, and then some of the transition metals and so on are down here. So really reactive metals would be our alkali metals, and then the reactivity would go down as you go along the series. The way we use the series is we take a look at the metal and the compound, and if the metal is higher on the series than the one that's in the compound, a reaction will happen, but if it's lower on the series, no reaction will occur. So our first example, we're going to try to react iron with sodium iodide, and if we take a look at where those things are, so here's sodium near the top and iron's down below, so we can see that nothing is going to happen. So if no reaction can happen, we write NR for no reaction. Our next example, we have sodium right up here trying to react with magnesium, which is lower down, so we know a reaction is going to happen. So if that's the case, then you rewrite the formulas to figure out what's going to happen. So sodium is going to displace magnesium, so magnesium is going to be by itself, and then sodium is going to join with oxygen. You'll have to do the little crossover rule to figure out what the chemical formula is. So we have sodium, we have oxygen, we look up their charges. Sodium gets a charge of +1, oxygen is a -2. We cross down the charges like so. So our chemical formula is going to be Na2O. Now we need to look and see, okay, is our reaction balanced? So we have 1 sodium on the left, but 2 on the right. So we need to balance this. But everything else is balanced. So now our equation is good to go. So a reaction does happen, and we've written the products and balanced the equation.